to my talk, Hunting Performance Problems in Node.js. I'm Daniel Kahn. You can find me on Twitter, and at this time there should be also the slides I'm showing now should be on Twitter already, and I have a few code examples via gists. You can then try it out later maybe. When I started in the industry, websites looked like that. So we see that cats already dominated the internet somehow, and Comic Sans was totally okay. In between, times changed. This was a thing I've done a few years ago. There we had already MongoDB, Scala Play, Node.js, everything. So things changed quite a lot, and I wouldn't have believed that I would stand in front of some people in Rome 15 years later and talk about performance problems in JavaScript. So because everyone hated JavaScript when I started, so there things have changed as well. Now I'm working for Dynatrace. We are creating performance monitoring product, and I'm there as technology strategist. This means I'm the Node.js guy there. When there are performance topics for Node.js, I go to customers, talk with them, what they are doing. These are customers like Intuit, Apple, PayPal, so it's quite exciting to see how they are doing. And then I go back into the lab and talk with the product management and try to get some features into the product. That's quite exciting, and that's why I look like that when I'm at the company. There are 2 or 3 slides that lead directly into the topic but show our product, but this is no shameless marketing talk, so no fears here. So performance monitoring is basically that. You have your application stack. If you have a single application, you don't need that, because I will show you later that with those tools that are at hand, you can basically trace every Node application. But when it gets bigger, you have something like that. As you see here, there's much going on. There are much tiers in your application. There are different tiers talking with each other, for instance, microservices. And there we already see one possible performance problem that's not directly located in Node.js. Those are those performance problems that are maybe in some API Node.js is using, because very, very often companies use Node.js as kind of gluing tier to talk to different APIs in there. And if one tier there is slow, then Node.js will appear to be slow, but maybe it's not Node.js to blame. And that's why performance monitoring tools of all vendors are made to discover your application stack and find out what's going on there. And then you get alerts. Yeah, you can figure that out. So there are calls, for instance, to external services that get slow, and then you will get an alert, for instance. And then there are also such Node.js metrics. And when I started with Dynatrace, they told me, okay, now you're the Node.js guy, go ahead, tell us how performance monitoring with Node.js works, tell us how the event loop works, tell us how memory management in Node.js works. And I found out that I actually, although I've done Node.js for quite some time, had not so much of a clue how Node.js really works. And it's not so easy, although Node.js is quite easy to start with, it's not so easy to understand what's really going on. And this is what I try to bring across in this talk, and for that we have to go to Mordor. I don't know, who of you is using Node.js in production frequently? Okay, who is just starting with Node.js? Okay, also a few. So my goal for this talk is that those that are new to Node.js will have a basic understanding what Node.js is, and those that are using Node.js already have learned something new here. So let's see if I can bring that across here. When there's bad press about Node.js, it's almost always about performance problems in some ways. There was this Node.js in Flames problem by Netflix, or this famous Walmart memory leak. And I will come to those a little bit later. Those are applications that have much users, makes sense. If this is your startup, you don't have a problem. There's a general rule, no users, no problem. So you're totally fine. But you may have no job in time as well. But I think the goal is always to have users and that, yeah, that your website or your application becomes famous. You get featured on TechCrunch the other day, and then you're suddenly this guy. You try to fix things in production. You have no clue what's going on, but it has to work because those hundreds of thousand users you maybe have paid for are now hitting your website. And maybe let's take one step back and let's look at what Node.js actually is, after all. So Node.js is, and I like this definition very, very much, because Node.js is a C++ program controlled by V8 JavaScript. Nothing more. It's not a language, it's just a platform JavaScript is running on. If we look at browsers, here we have Google Chrome, because the V8 engine Node.js runs on was made for Google Chrome. And Chrome provides a DOM, bindings, and the event loop to the V8 engine. Makes sense. The event loop, for instance, you need when you click on the button on a website, something should happen. Something has to wait for this event and do something at this event. When it comes to Node.js, it looks like that. So you have your code here. Then you have this Node standard library that provides all those Node-specific JavaScript functions to you. Then you have this bindings. Makes sense. You have to talk to your operating system, for instance. When you have it in your browser, you want to do a console log, and it should be down there on the browser. When you do that on a Node application, you want to have something going on the console of the standard out of your application, of your server, maybe. And then we have the V8 engine that passes the JavaScript, and then we have a thread pool and the event loop. And I will explain that a little bit later, but everything is handled here by a library called libuv. Here's a little example that just shows, again, how things are working. So require, obviously, is a core library function. Then you have some system bindings for console log, maybe. And then you do a read file, for instance, and you delegate this to the event loop. This is, in a nutshell, what Node.js does. And if we have this JavaScript here, we throw it into the V8 engine. And the V8 engine compiles this down, not to bytecode, but to pure assembly code. It's native code on your system. And every time we have a program running, I think it's represented through two things. It's something going on the CPU, and something going on the memory. Makes sense. And maybe these are those fields we should look into when dealing with performance problems. And I start with memory here. As we see, Node.js organizes the memory very much like Java. So we have this whole memory block allocated by a Node application. It's called residence set. Then we have the code segment. That's your JavaScript code that you actually wrote and that is compiled down. Then you have the stack. Here are local variables, some pointers. And then you have a space allocated that is called heap, like in almost every platform. In this heap, we have one section that is the used heap. This means that Node.js will allocate a space in memory, and only a fraction of it will be actually used. And if there is more, and it will grow when the used heap grows to some threshold, it will grow. In this heap, we store objects closures. And this is already a field where much is going on, where there can be problems. Finding out what's really going on in your memory in Node.js is extremely easy because you just have to do process memory usage. This is a core function. So, and every time, and if you do that, you get something like that. Here you have again the residence set, you have the heap total and the heap used. And every time we have something we can call periodically in our scripts, it's tempting to log this data out and create some graph of it. And this is the result of that. This happens when you run a Node application and run this process memory usage on it. And we see already, here we have our resident set, here we have the heap, and here we have the heap used. We already see that there is much going on there. So we have this sawtooth pattern. So this is really a volatile thing. So there's some process in place that takes care of that. Talking about memory management, it makes sense to go back to the roots and look at how C does it, for instance. Every time you want to use memory, you have to allocate it. And every time you want to get rid of memory, you have to deallocate it. Makes sense. On V8, it wouldn't even work to allocate or deallocate in JavaScript, because what you do in JavaScript has nothing to do with the representation of your data in the V8 engine on the native layer. And there are also other problems. And when you deal with memory allocation, deallocation, because you can maybe forget it and you have to do all this housekeeping to keep track of all your allocated memory segments. And this is, you might have guessed already, we are talking about garbage collection. That's an Austrian garbage collector. And garbage collection works in principle quite easy. So you have this whole root space. So this is for instance, a browser, or this is your Node application. That's the global space, the global object. And then we have some data laying around here. Let's build this data up. So here we go. As we see here, this blue object is a reference by the root object. So this is the first thing you need. So every time an object is referenced by the root namespace, it makes sense to keep it. So the garbage collection engine in Node.js simply does housekeeping and looks which object references which object. And as you see already here, this is a graph. And an object is always to be erased if there are no incoming paths into an object, if nothing is referencing this object. So let's look when we can actually garbage collect this thing. So let's remove this, let's remove this, let's remove this. Nothing happens, so this object will still stay in memory. If this root reference is gone, we finally can remove this reference, and then we can remove this object. This is, in a nutshell, everything garbage collection does. In a very tiny nutshell, because it's quite complicated, because this whole housekeeping means that Node.js keeps track of the V8 engine, keeps track of how long objects in the memory, are those new objects, or are they old? Can we move it from one space to another? Are they large? Are they small? So there's much going on in the background to keep this performant. And there are two ways of garbage collection in Node.js. One is the scavenge compact run. Scavenge compact is a quick run, and just, objects that can be easily removed will be removed in this run. And then there is the mark sweep. It's a quite expensive thing. You have to know that every time a garbage collector runs, Node.js will stop and the garbage collector will run. So this is a performance impact. So this mark sweep has more performance impact, but will really clean up the memory big time. And when we look at this again, it makes sense. So we have this scavenge compact runs here that make this upgoing sawtooth patterns, and then we have this this mark sweep runs that will really free much memory, and this line goes down here. Makes sense? Okay. We can also graph this out, and here I show the first time how easy it actually is to get such information out of V8, because V8 has its APIs you can use from Node.js through some modules that just export native V8 API functions to Node.js, and there you can simply use Node.js profiler, subscribe to the GC event, then you can really graph out or log out all mark sweep runs and all scavenge compact runs. This is already one step into your own monitoring solution, actually, because you can really look into your garbage collector anytime. And when you use this in a product, this is again our product, it looks like that. That's a result of this, what I've shown you before. So it's quite easy to do that. As you see here, we are also graphing out how long garbage collection takes. Makes sense, because if maybe you have an application and you are reading some data from a file and store it in a variable, and this has to be freed at some point, and you find out there's very much time used for freeing up the memory and using garbage collection on that, it makes maybe sense to, for instance, use streams for reading this data, to not allocate memory for that. So that gives you some hints about problems here. So now we have a garbage collector, we have the V8 engine, everything is dealt with, we have no problem, actually we can go home, so we have a happy end here. Unfortunately not. And to understand this, we have to visit my hometown, that's Linz in Austria. And this is my house where I live. And this is the backyard here. This works, by the way, way better in the US. So, because the house was built around 1600 something. And for them, this is extremely old, but who am I to tell something about old buildings in Rome? So, it's not so spectacular here. And there is this room, so where we store our garbage. And there we have this, since I'm at this flat, there is this TV set standing around, and they have a sign on it, this, which tells, bitte nicht hier abstellen und gleich selbst entsorgen, which means, just please put it away, we won't do that for you, just, deal with that. And if this happens in your code, it looks like that, and we call it memory leak. When you have this memory leak, Node.js, when it dies, will spit out some information about how it died and how severe this whole problem was. And here you are. And this might be the place where you spend your weekend, because you try to find the problem. And I thought, okay, is it so difficult to really trace down memory leaks in Node.js? So there are the simple ones. You decide to store the IP address of every user that hits your website in a global variable, in a global array, all the time. And you have built your own little nice memory leak, but this is way too simple, actually. So, but there are different ways, and I thought, okay, let's search for a really, really complicated case of memory leak, and where it's not so obvious what's really happening. And I came across the Meteor site, and they described a memory leak that has actually this pattern. And there will be a slide after that will describe it a little bit better again. So we have, the thing is a variable, and we have this function. And this is called for every hit. This is an express route. So every time this route is called, replace thing will run. And it will print out everything is fine, which is not right. And here we have original thing which references just this thing out of the global namespace. And here we have a function that is actually never called. It's called unused, but it references the original thing again. And then we have an object here. And this object contains a long string array of, I don't know, 100,000 or so asterisks. And then we have a closure here that just does a console log. So this is not doing anything. It's a quite senseless and meaningless piece of code, actually. The problem we have here is, if we look at the way things reference each other, is, okay, we have the thing here, which contains long string and some method. We have the root object, and yeah, this the thing is referenced by the root object. And then we have this unused function, which is, and that's the interesting part, we have this closure here, the sum method closure, and every closure will have a pointer to its enclosing scope, because it needs it to access variables of the enclosing scope. So some method will know this function unused, and this function unused references again or uses original thing, but never does anything with that. And original thing is actually a reference back to the thing here. And this is not totally wrong. And when we look back, I just want to show you this example again. If we look back, one would think that every time this route is called, the thing gets simply overwritten here. But because of this deep references we have here, the V8 engine simply gives up. This is just too much indirection, and V8 will say, okay, deal with this yourself, I can't follow this path here. And when you create something like that, and you have this memory leak, it will look like that. So you have memory constantly climbing up in your application. Maybe not so quickly, because we have here allocating quite some data, but in the end, it will somehow look like that. So it makes also sense to, and I will show you this, or I've shown you this already, actually, to look at those memory usage with process memory usage and log it away, graph it out, find out if there is something constantly growing, then this might indicate that you have exactly such a problem like that. In this case, this could be solved quite easily, because you can set the thing simply to null at the end of the function. Then you will tell the garbage collector, okay, dispose it. But yeah, you have to find it first. That's the problem. And what if we could look into the memory when something like that is going on, to find out what's really, what's now in the memory, where is this everything allocated, what's wrong here. And for that, and that's just an example, I used V8 Profiler. So this, again, just uses the capabilities the V8 engine is giving you already. So that's nothing dedicated to Node.js. And what you can do is, you can tell the profiler to take a snapshot, serialize it, and then maybe write it down to somewhere. When you do that, it doesn't help you to create just one snapshot, because you don't know if anything is growing if you don't have a delta. So it makes sense to employ some anomaly detection in some way to find out, okay, something is growing, take a snapshot. It's growing again, take a snapshot again. And this is what this code example here shows to you. It just looks at some at the previous memory usage and the next and the current one, and then we'll say, okay, there's something odd, some threshold is was exceeded, and then we'll create a snapshot for you and store it somewhere in the file system. So how much time do we have? Okay. And I try to show it. Those screens are quite small, but I try it. So live examples are always a risk. Please stay with me. I've created a few snapshots. We can inspect now. So here we are. So this is Chrome Developer Tools. Who doesn't know Chrome Developer Tools? Okay, yeah, a few. So when you use Chrome, just go to the menu, select Developer Tools, and this is what will open. So you can look at your HTML code, and there are also this profiling facilities in there. And the nice thing is that you can use every profiling facility made for the Chrome browser with the data you get in Node.js via those V8 APIs, because they are the same APIs actually. So let's load 3 snapshots here. So I've created this. It's exactly the memory leak I've shown before. And I've created 3. Because when I look at this, it's hard to tell if something is wrong. There are functions laying around, so what should I do with that? Can you read it in the last? Yeah. And here I have the possibility to go to comparison and compare the last one, for instance, with this one. And the problem, actually you see this problem already building up somewhere here if you look at that, but that's a little bit too evolved to show it here, but here you have it. So what I've done, I have a delta, I've sorted it by the allocated size, and as you see here we have our asterisk string again. So this is the memory leak we've created, and we have found it here. That's still maybe not so easy in all situations, but still, this shows how you find memory problems. That's the only way you have, and you can do it like that. So would we be able to find this Walmart Node.js memory leak? They had the problem that after some time, always the memory was just slightly, but was constantly growing, and they didn't know why. Unfortunately, not so easy, because in this case, this was a problem within Node Core. You see there is the function, or this allocation of handle scope. If you skip this, the data allocated within this function will be scoped globally and will be freed when you restart the process. This is what they did, and this leaked 4 bytes with every call, and that was really hard to fix, and actually it needed some guys of the Node Core team to really find this problem. So that was a hard one, but I still think that we have so much chances to screw something up in our code that we still can rely on the tools I've shown you to fix them. So, because still this is a bit lame, and that's why I show you a cat. It's also because we are kind of in the middle of the talk. And then there was this Node.js in Flames problem, and this is something we might be able to fix. Actually, Netflix had this problem that after some time, the request times really were jumping up, and no one knew what really was going on. And they had to reboot the server to get it going again, so that was a big problem. And this was actually a CPU problem, because here we have Node.js how it works. You have read file function, and this read file function tries to read a file. This runs through the event loop, actually, because you delegate it to the event loop and say, please, event loop, read this file for me. And when it is done, please run this function with the data you got, in this case, the content of the file. And this is fine this way. This is completely asynchronous and great. But what if the other day someone comes and tries to calculate Fibonacci in there? Because he might think Node.js is asynchronous, so I can do anything with that. And here I have an asynchronous function, so I can do this in the callbacks. This will cause your main thread to block. And your application won't take any more requests after that. So as long this Fibonacci runs, there will be no request running through your application. The whole main thread is blocked because Node runs in one single thread. You can use the cluster module, but then you block this one cluster process for a time. To trace such problems down, you can use that. This was the reason why I had this whole welcome to Mordor idea in the first place, because it looks a little bit like Mount Doom and that I don't understand it, so it's just too complex for me. And I thought, what if we can simply walk into Mordor? And again, I used V8 Profiler for that. So you can, profiling is, I think, quite clear. You can look into the CPU for a given time and take snapshots and look which function and which function call stack is actually running on the CPU. And this is what you do here. So you say profiler start profiling, then stop profiling, and then you can serialize out this data again. What you get here is totally easy. It looks like that. But it really is, it's actually a tree, a JSON object. And you can again feed this into Chrome Developer Tools and sort your functions on this call stack by heaviness. So how long do they stay on the CPU? And here I've created some prime calculator, and it will clearly show up that there is some problem. But this is a simple case, because that's one function that is to blame for some blocking things. What if there is a whole bunch, a cluster of functions that create the problem? You can again use a flame chart like thing, but I still don't understand it, and I just skipped this for me, and I thought, okay, there must be a simpler way, and I came up with something that's called D3. D3 is a JavaScript library used to graph out data. And I really like these sunburst charts because they look fancy and they tell you something. And I had this interesting problem. I was researching on that, on the difference of what happens when you use Express with the Node environment set to production versus development. Is there a difference or is there no difference? And we see there is a huge difference, because those are the same amount of requests to run it against the application, and you see it takes 75% longer if you are in development versus production. So the application is 75% slower in development mode with Express. And this wouldn't be so much of a problem, but the problem is if you don't explicitly set node-env to production, Express will default to development. And I don't know how many applications are out there that are running in development mode, and no one knows that. So that's basically a severe problem. And if you put this on such a sunburst chart, this looks quite fancy. So this is in development mode, and this is in production. And this is no rocket science to see that there is much more going on this development mode. So there is much more going on the CPU. And I was asking myself, okay, what is this? And this is something I will show you short. So how do we do it? You just have to open this thing here. Yeah, here you go. Then I have to close this one here. So 1 second, stay with me. What you see is so fancy, you will be surprised and amazed. This is the result. So what we see here in the middle is the root function. So this is the whole time slice we took from the CPU. And these are all those child objects. And section by section, these are childs of childs of childs. This is just another way to represent the tree. And if we go into this here, I don't know if you see it from back behind, but this is all blamed to Jade. That's a template engine that is running. It totally makes sense. In development mode, Jade will compile your HTML template with every run. Totally legit. The problem again is that Jade picks up the development mode of Express and uses it. And again, the problem is if you don't set it explicitly to production, you will exactly have this result. And I think that's an interesting way to show how CPU sampling can actually help you to find problems in your code and to find really complex problems in your code where it's not only one function that is slow. There are many, many slow, many tiny functions going on here. That's all fine. Such things can be found when you run it, when you are developing on a development machine. Makes all sense. What I want to add in the end is you should do load testing. You can only find leaks and problems when you do load testing, and there are plenty of tools available. If you use a MacBook, you have already one installed. It's called AB. It's Apache Bench, and you can run it against the application and really see, okay, is there something going on my application? Is there something wrong? And to wrap this whole thing up, so we have this process object in Node.js. We have the V8 profiler, for instance. So with all those API functions, the V8 engine provides us out of the box. We can get the memory usage. We can get heap dumps. We can get CPU dumps. And we have Chrome developer tools to analyze that. So why don't you create your own monitoring dashboard and build in switches into your application to, with one click, switch on memory profiling for some time, or do some CPU dumps to find out what's going on if there's something wrong. So that would be quite easy, and you can really do this in runtime and switch off or switch on things here. And then you end up there, back in Shire. So we have left Mordor already, and everything would be fine. Thank you. Questions? A question for you, those that are with Node. Have you heard anything new here? Who has heard something new? Ah, still, yeah, that's a success. And the new ones to Node, have you got some impression how Node.js actually works? Not so much. Okay, yeah. We should do this intro in Node.js talks, really. Yeah. Does anyone have a question here?
Is there any way to connect directly the Chrome DevTools to a Node running instance?
There is a tool. Is it called? I think Node Debug or something. There is Node Inspector. Exactly. There you do actually that. So this will show you that, and you can run it. But that's not so much a thing you may want to do in production, maybe, as far. So it's more or less a thing you want to use when you're debugging in development, but it exists. Node Inspector.
I was thinking more along the lines of, like you do in Java, you can attach directly to a running JVM.
Mm-hmm.
So you can run your JConsole Visual VM against the running instance. So I was thinking about something along those lines.
Not so much like that, so that you can really, but Node Inspector comes close to that actually. You have it in the Chrome developer tools. You can even do some watches there, so there's much you can do, and it's web-based actually, so you can, and it will show you those metrics that are in Chrome developer tools as well. So check this out. This might be what you're looking for. Okay, thank you.